Okay, in this section we're going to be looking at polygons, and specifically the sum of the angles in different polygons. So the word polygon just comes from the Greek meaning many angles, okay? So we're just talking about any shape here when we talk about a polygon. Sorry, poly means many, not any. Okay, let's take a look at this chart here, and we're going to have a go at filling it out, and I'm going to start it for you. And what I'd like you to do is stop the video when you think you've kind of got the pattern and try and fill out as much as you can on your own before going back to the video to check your answers. Okay, so if we take a look here, our first shape is a triangle. So we know a triangle has 3 sides, and within a triangle there's only one triangle, and you'll see what I mean by this when we look at some of the other shapes. And we know already that the angles in a triangle sum to 180 degrees. Okay, next one is a quadrilateral, and a quadrilateral has 4 sides, and the number of triangles we can divide a quadrilateral in, so sorry, that's quite a bad looking line. I'll try that one more time. Okay, so if we were to go from one corner to the next, you'll see that a quadrilateral can be divided into 2 triangles. And so the angle sum is 180 degrees times 2 triangles, which equals 360 degrees. Okay, now let's look at a pentagon. So if we tried to divide a pentagon into angles, into triangles, you can see that we can divide a pentagon into 3 triangles. So we've got a 5-sided shape that can be divided into 3 triangles. So the sum of angles in a pentagon is going to be 180 degrees times 3 this time, because we've got 3 triangles, which gives us 540 degrees. Okay, you might be starting to see a pattern now, and you might think, oh, I'm going to try this on my own. If not, we'll do the next one, hexagon. So if I divide my hexagon into triangles, I've got 1 triangle there, 2 triangles there, 3 and 4 triangles. So a hexagon is a 6-sided shape, and it has got it's divided into 4 triangles. So the sum of angles in a hexagon is going to be 180 times 4, which gives us 720 degrees. Okay, so the angles, the interior or the inside angles in a hexagon sum to 720 degrees. Okay, a heptagon is a 7-sided shape. So let's try and divide our heptagon into triangles here. And you'll notice I always start at one point and kind of go out, just so that I know I'm dividing the shape up into triangles properly. Okay, so I've got 1, 2, 3, 4, 5 triangles now. And that means that to work out the sum of the angles in a heptagon, I need to do 180 degrees times 5, which gives me 900 degrees. Okay, an octagon, I'm not going to draw it in this time. Let's take a look at the pattern. An octagon has 8 sides, and you'll notice the number of triangles in each shape is 2 less than the number of sides. So if we look back at the triangle has 3 sides and 1 triangle. And a quadrilateral has 4 sides and 2 triangles, and a pentagon has 5 sides and 3 triangles. So actually, to go from the number of sides to the number of triangles, I've been subtracting 2 each time. So that tells me, without even doing it, that in an octagon, I'm going to have 6 triangles. Okay, so to work out the number of angles in an octagon, I would do 180 times 6, which gives me 1080 degrees. So that's the angle sum, the sum of interior angles in an octagon. Now let's just look at how we can write this in general. So if we have an n-sided polygon, and that just means, we want to find the general rule no matter how many sides we have. So in an n-sided polygon, we would just have n sides. So we would call the number of sides n. And we looked at the relationship between the number of sides and the number of triangles, and we decided that that was the number of sides minus 2. So in this case, the number of triangles is going to be n minus 2. Okay? And to work out the angle sum, we were always doing 180 degrees times the number of triangles. Well, in this case, the number of triangles is n minus 2. So our general formula for working out the sum of angles in any polygon is to do 180 degrees times n minus 2, where n is the number of sides. So in this case, it says find the angle sum of a decagon. So I'm just going to write our formula in here. So the sum of the angles is 180 degrees times n minus 2. Now in this case, n, remember, is the number of sides. So a decagon is a 10-sided shape. So n is equal to 10 in this case. So I'm going to substitute n is equal to 10 into my formula. So I'm going to do 180 degrees times 10 minus 2. Okay, and remember I need to work out what's in the brackets first. So that gives me 180 degrees times 8. So 180 degrees times 8. Let me just work that out on the side here. 8 times 0 is 0. 8 times 8 is 64. 8 times 1 is 8. Plus 6 is 14. So the sum of interior angles in a decagon is 1,440 degrees. Okay, our next problem says find the size of an interior angle in a regular octagon. Now regular just means that all of the sides and all of the angles are equal. Okay, so a regular polygon has all sides, I'll write that down for you, all sides and all angles are equal. Okay? So the first thing that we're going to have to do is what we should do is we'll find out what the angle sum in a regular octagon is, and we actually did this on the last page, but just using our formula because you might not have that page with you all the time. Remember we need to do 180 degrees times n minus 2. In this case n is 8 because I've got 8 sides in an octagon. So I'm going to substitute n is equal to 8 into my formula. And that gives me 180 degrees times 6, which is, so 180 times 6, 0, 48, okay, is 1,080. So that's the sum of all the angles, but we just want to find the size of one of the interior angles. Now they're all equal and there's 8 angles in an octagon, so I can just divide my sum by 8 to work out the size of one angle. So 8 into 1,080. 8 goes into 10 once with a remainder of 2. 8 goes into 28 3 times with a remainder of 4, and 8 goes into 45 times. So that means the size of an interior angle in a regular octagon is 135 degrees. Okay, and in this question we need to find the value of A in this pentagon. So in order to work this out, we need to know what the sum of angles in a pentagon is. Okay, and you might remember this and you might not. So if you don't remember, again, just use the formula 180 times n minus 2. N in this case is 5 because we have a pentagon. So if I substitute that in, I get 180 times 5 minus 2. So 180 times 3, which is 540 degrees. So I know that all 5 of those angles must equal 540 degrees. So I can write an equation now, like we were doing with triangles and quadrilaterals. So A plus, now all the other angles I know, so 170 degrees plus 80 degrees, plus that right angle there, 90 degrees, plus 95, must equal 540 degrees. Okay, so I'm going to add up all the angles I do know. So 170 plus 80 is 250, plus another 90 is 340, plus another 95 is 535. Is that right? Okay, let's try that again. I'm actually going to write this down because I'm having trouble doing it all in my head. So 170 degrees, 80 degrees, 90, and 95. Okay, 5, 7, and 8 is 15, plus 9 is 24, plus another 9 is 33, and 3 and 1 is 4, so 435. Okay, so A plus 435 has to equal 540. So to work out A, I'm going to do 540 minus 435, which gives me a value of 105 degrees. Okay, so we're done this section here. If you'd like to go ahead and write your summary and come up with your question for class tomorrow now.